Okay, in this video we're going to look at quadratic relations. So we've looked at linear relations in grade 9 and grade 10, and that is y equals mx plus b, or ax plus by plus c equals 0. So now we have quadratic relations which look in standard form like this. So y equals ax squared plus bx plus c. Okay, so we want to take a look at what some graphs of these look like. So we're going to look at graphing these quadratic relations. The standard one that we're going to look at is just basically y equals x squared. So we're going to be coming back to this one a lot. So y equals x squared. If we take a look at a table of values for this, just to get the basic idea of it, so if we let x equal, say, -4, -3, -2, -1, 0, 1, 2, 3, if we take a look at those numbers in the table of values, well, we can go to 4 as well. When we square these, so we sub these in for x, when we square them, well, when we square 0, we get 0. When we square 1, 1 squared is 1. So is -1 squared. -1 times -1 is 1. When we square 2, we get 4. When we square -2, we also get 4. When we square 3, we get 9. -3 squared, also 9. 4 squared, 16. -4 squared, so -4 times -4, also 16. So we have some symmetry in this table of values here. Okay, so basically on either side of 0, it's the same y value. So when you go to plot something like this, just roughly if I draw an x and y axis, well, at 0, 0 we have a point. Okay, if you go over to the right one, left one, well, 1 and -1 squared is 1, so we can go up 1. If you go to the right and left 2, so 1, -1, there's 1 on the y-axis. Okay. If we go to 2 on either side, well, then the y-coordinate is 4. So you go over 2 from the 0, 0 point, then you go up to 4. Okay. So you plot a point there and there. Definitely not going to create a line, is it? It's going to be a bowl-like looking thing. And then if you go over 3, well, then you're going to go up to 9. So there's 4, so 8 would be about there. 9 would be way up here somewhere. And you're going to have points that are like this. So the symmetry in this table corresponds to symmetry in this graph. Okay, so we can join those points, make them x's so you can see them afterwards. Okay, so join those points smoothly as possible. And it shouldn't look like a V. It should look like a nice curve that keeps increasing faster and faster. Okay, and that's what the basic quadratic relation will look like. And all of them will look like a variation of this, moved around or the shape changed a little bit. If you imagine that that was -x squared, then you square the number first, then multiply it by -1, all these y values become negative. So -x squared would have the effect of having the same shape but opening down. Okay, so all these y coordinates would be negative instead of positive. Now, let's take a look at this quadratic relation here. Y equals x squared minus 2x minus 8. If you do a table of values for it, just by subbing in numbers, so I did a bigger variation of table of values than this one. Okay, if you do a table of values for this, then you get this table of values. I went from -5 to 5 just to see what would happen. And when we do that, we plug in 0. 0 squared, 0. Minus 2 times 0 is 0. Minus 8. Okay? So when I plug in 0, I get -8 for y. I plug in -1. -1 squared is 1. Minus 2 times -1, well, that's going to be plus 2 then. So 1 plus 2 is 3. Minus 8 is -5. So when I plug in -1, I get -5. You keep doing that for plugging in all these x values, and you get these y values here. When you get this table of values, you notice some symmetry again, but the symmetry is not at 0. The symmetry is around here. So at -9, on either side, you got -8, then -5, then 0, then 7, and I'm sure you'd have the same thing if you kept going. So I just picked the symmetric portion of this. Okay, and if I got to plot this, well, this is what the graph will look like. Okay, so I plot the -1, -9, -1, -9 down here. Okay, and then I plot the 0, -8, so that point, and the 2, -8, that point, so the symmetric points there. And then I go to -5 for the other ones, and 0, and then 7, and that gives me the basic shape of that parabola. Okay, so these shapes here, these shapes of quadratic relations are called parabolas. So let me write this down here for you. So it's a parabola. Okay, so that shape's called the parabola. Now, in this, when we look at it, we can see the y-intercept. Okay, it's -8, and we can see x-intercepts in this one. Okay, this point at the very bottom here, the sharpest point of curvature, is called the vertex. So we have the points of the vertex here. For the standard quadratic, y equals x squared, the vertex is at 0, 0. Okay. So this one, the vertex has moved when it's in this not as nice a form here. Okay, so we can then add to the table of values here, we can add the x-intercepts are right when y equals 0. Okay, so when y equals 0, we have the x-intercepts, 4 and -2. So in the graph, it's 4 and -2. And we also have the y-intercept. The y-intercept happens when x equals 0, and that is -8. Okay. Now what happens when we change the form of this here? So we've seen factoring quadratics, and we've seen completing the square. So let's try both of that to see what happens. Okay, so when we factor this quadratic here, well, we can use product and sum. So the product and sum, product is -8, sum is -2. Two numbers that multiply to -8 and add to -2 are 2 and -4. And you can then directly factor it to x minus 4, x plus 2. Okay, now in this form, if the y was a 0, thinking of quadratic equations, if the y was 0, then x equal to 4 and x equal to -2 would be solutions. So if you wanted to find out the x-intercepts, well, you set y equal to 0. Okay, so when y equals 0, x equals 4 and -2. Well, 4 and -2 are the x-intercepts. So what's neat about this form is, if we can factor it, we can tell directly what the x-intercepts are. Okay, and that will help us from ever having to do this table again. Now, so here's the case. Now let's complete the square. So if we were to complete the square on this, so y equals x squared minus 2x minus 8. Take half of this number, square it, add it, and subtract it. Okay, so half of -2 is 1, -1. 1 squared is, or -1 squared is 1. Add it, subtract it. This is now a perfect square. Okay, that perfect square is x minus 1 squared, and then negative 1 minus 8 gives me negative 9. Now we've completed the square. Now, some important numbers that pop out from here are, well, let's think of what value could I sub in for x here so that 9 was the y. Well, if I subbed in 1, 1 minus 1 is 0. 0 squared is 0, so y equals negative 9. What's neat about this form is we can get the vertex right from it. So when we complete the square, we can put it in what's called vertex form. Okay, so the vertex in this one is 1, negative 9. That's the lowest point on this curve, 1, negative 9. Okay. Now this happens to be the minimum for this one. Okay, so that's the sharpest point of curvature is the vertex.